Good morning, everyone. Today we are going to discuss our fifth section in solid waste management. One of the techniques to deal with waste is the combustion of waste. We use this method to generate heat from the waste. Carbon, hydrogen, and sulfur are the major elements in municipal solid waste. These components are needed for combustion. The reactions are carbon plus oxygen gives carbon dioxide. Of course, here we are talking about complete combustion. Hydrogen plus oxygen gives us water vapor, and sulfur plus oxygen gives us sulfur dioxide. Note that all the reaction needs oxygen, so when we calculate the amount of air we need to take into consideration that the oxygen is 23% by mass. So, if your calculations lead to 2 grams of oxygen and you want to calculate the air mass, then you need to divide by 23%. But now we need to know the amount of oxygen needed by the carbon, hydrogen, and sulfur. So we can calculate the amount of oxygen needed, by which we can calculate the mass of air needed for the combustion. The aim of this section is to calculate the amount of air needed for complete combustion. So if you are going to use your waste for heat generation by combustion, you know the air mass that you need for complete combustion. Now let's start our calculations. Our first formula is carbon plus oxygen gives us carbon dioxide. As you can see here, 1 mole of carbon needs 1 mole of oxygen to produce 1 mole of carbon dioxide. Now we need to calculate the mass needed, and as we know, the moles multiplied by molecular weight gives us the mass. So using the molecular weight for each of the components, carbon, oxygen, carbon is 12, oxygen is 16, then we know that 12 grams of carbon needs 32 grams of oxygen to produce 44 grams of carbon dioxide. To make something general, we can say that 1 gram of carbon needs 2.67 grams of oxygen. We get that by dividing all the numbers by 12, so we get the mass needed of oxygen for 1 gram of carbon. Now we are going to do the same procedure, but now with the hydrogen. The formula is 2 moles of hydrogen plus oxygen gives us 2 moles of water. So, using the molecular weight, which is 1 for the hydrogen and 16 for the oxygen, we know that 4 grams of hydrogen needs 32 grams of oxygen to produce 36 grams of water. By dividing all the numbers by 4, we get that 1 gram of hydrogen needs 8 grams of oxygen. Now with the sulfur, sulfur plus oxygen gives us sulfur dioxide. The molecular weight for the sulfur is 32, for the oxygen is 16. So 1 mole of sulfur, which is 32 grams of sulfur, needs 32 grams of oxygen to produce 64 grams of sulfur dioxide. Now by dividing by 32 we get that 1 gram of sulfur needs 1 gram of oxygen. So what we can conclude from all our calculation is that 1 gram of carbon needs 2.67 grams of oxygen, 1 gram of hydrogen needs 8 grams of oxygen, and 1 gram of sulfur needs 1 gram of oxygen. What we are going to do is we are going to calculate the chemical formula as we have discussed in section 2. After knowing the chemical formula, now you know the number of moles of carbon, hydrogen, oxygen, and sulfur. All what you are going to do is to calculate the amount of grams of oxygen that you need per the chemical formula. Then you are going to add all the oxygen needed together, and this is the amount of oxygen needed. Don't forget that if you want to calculate the amount of air needed, not the amount of oxygen, then you need to divide the amount of oxygen needed by 0.23. Now let's start solving some examples. Question 1 wants to know the amount of air needed per 1 ton of waste in the unit of kilograms. Here, as you can see, the chemical formula is given, so CHO and S. And as you can see here, C50, H100, O30, and S1. Now you need to calculate the amount of oxygen needed. Then you are going to convert it to the amount of air needed. Note that there is oxygen in the chemical formula. So this amount of oxygen will react first, and you don't need to supply oxygen at first. So the amount of oxygen found in the chemical formula will react with the hydrogen. Then we are going to compute the amount needed for the carbon, the remaining hydrogen, and sulfur. Let's see step-by-step solution. We have C50H100O30S. So the total mass is the number of moles multiplied by the molecular weight. So 50 times 12, which is the molecular weight for the carbon, 100 multiplies 1, which is the molecular weight for the hydrogen, and so on. And then you get 1212 grams of waste. Each 1 gram of hydrogen needs 8 grams of oxygen. And as you can see here from the chemical formula, the amount of oxygen provided by the waste is 480 grams. As we said before, this amount of oxygen will react first with some of the hydrogen found in the waste. So, knowing that 1 gram of hydrogen needs 8 grams of oxygen, then we need to calculate the amount of hydrogen that will react with 480 grams of oxygen available in the waste. As you can see, by cross multiplication you will get that 60 grams of hydrogen will react with the available oxygen. Now you need to provide the waste with additional oxygen to perform combustion on the remaining hydrogen, carbon, and sulfur. So first you need to calculate the remaining hydrogen, which is 100, the original amount of hydrogen, minus 60, the amount of hydrogen reacted with the available oxygen. So you get that the remaining hydrogen is 40 grams. So now the remaining amount is 600 grams of carbon. It's not different from the original. The hydrogen is 40 grams. Now oxygen, all of it is reacted with the hydrogen, so it is 0, and sulfur is 32 grams. Please note that the total weight of the waste is 1212 grams. It is not different from the original because the oxygen remains in the original waste. However, it's 0 in our remaining calculations only. Now it's simple. You know that 1 grams of carbon needs 2.67 grams of oxygen. And now there is no remaining oxygen in the waste. So you need to provide the oxygen to perform combustion for the total amount of 600 grams of carbon in the original waste. So by performing cross multiplication, you know that the 600 grams of carbon needs 1602 grams of oxygen. Similarly, you know that 1 gram of hydrogen needs 8 grams of oxygen, so the 40 grams of hydrogen remaining in the waste will need 320 grams of oxygen, and the 1 gram of sulfur will need 1 gram of oxygen, so the 32 grams in the waste of sulfur will need 32 grams of oxygen. So the total amount of oxygen needed for the combustion of 1212 grams of waste is the summation of all the oxygen amounts calculated in the previous slide, which is 1602 plus 320 plus 32, which is equal 1954 grams of oxygen. Now, this is the amount of oxygen needed. However, we need to compute the amount of air needed. So, we will need to divide this amount by 23%. After doing so, the air needed is 8,495.65 grams of air for the combustion of 1,212 grams of waste. However, this is not what we need because the question is the amount of oxygen needed per 1 ton of waste. Now, we said that 1,212 grams of waste needs 8,495.65 grams of air. So, we need to compute the amount of grams of air needed for the combustion of 10 power 6 grams of waste, which is equivalent to the 1 ton. By performing cross multiplication, you will find that you need 7,009.6 kilograms of air for complete combustion of the waste. To conclude what we have said, the answer guide for any question asking you to compute the amount of air for oxygen needed for the combustion of a given amount of waste. First thing, you need to get the amount in grams for each component. If you have the chemical formula, note that the chemical formula provides you with the amount of moles for each component. So you need to multiply the amount of moles by the molecular weight to get the mass. Second thing, you have an oxygen in the chemical formula. This available amount of oxygen will react with the hydrogen. So calculate how much of the hydrogen will be consumed by the available oxygen and calculate the remaining amount of hydrogen. Note that the remaining amount of oxygen will be zero because it will be consumed by the hydrogen, and only the hydrogen will have a remaining amount in grams. However, carbon and sulfur will not be changing. Third step is to calculate the oxygen amount needed for each weight of component. The summation of the amount of oxygen needed will give you the amount of oxygen needed for the complete combustion of the waste by the given chemical formula. Last thing, don't forget to calculate the air requirement of the waste by dividing the summation of oxygen needed by 0.23 because oxygen is 23% by mass of air. Kindly don't forget, if the question asks you to compute the amount of air needed per 1 ton, 2 ton, or a given amount of waste, then after you compute the amount of air needed for the given chemical formula, calculate the total grams of the chemical formula, then convert it by using cross multiplication. Here, as you can see, question 2, it's the same. It needs the computation of the amount of air needed in kilograms for complete combustion of 1 ton of the waste. It gives you the chemical formula. As we said before, here the chemical formula is given. So first of all, you are going to calculate the amount in grams for this chemical formula. Then you are going to compute the amount of hydrogen consumed by the available oxygen. Then you are going to compute the oxygen needed by you to provide for the remaining hydrogen, carbon, and sulfur. Kindly note that nitrogen is not used in combustion. Here I provide you with the final answer for the question, so kindly try to calculate it yourself. In question 7, as you can see, it's kindly a big question. So in this question, the question provides you with the amounts of the components in the waste: food waste, paper, cardboard, plastics, and the total, the wet masses, dry masses, moisture kilogram, and the component in each one of them. What you need to know is that all of these sections are interconnected. So you're going to use section 2 and 3 so you can compute the chemical composition of this waste. Then you're going to use the steps in these section to calculate the amount of air needed for this type of waste. Here I provide you with the final answer, so kindly calculate the answer yourself, and I'm waiting for your feedback. Thank you so much, and if you have any question, I will be available in the online chat room. Goodbye.